wait a bit. Since this is a pretty short section compared to some of the other ones. Give them a few more minutes.
So Ray, you could hold off a little bit until he's ready to go.
Oh,
Yeah, I just don't want to forget to start it.
so do we need to fill in with jokes or whatever until we actually get started? I don't know many good ham radio jokes.
And if it's being recorded, you don't really want to say them, right?
Right.
Uh-oh, Randy just took off.
Well, should we get started?
Yep. We've got the important ones here.
Okay.
Emery and Marina.
Randy's coming back.
Okay.
Yeah, but he's not a student.
I will go with my screen share now and see if we can get that. Shouldn't be this one. Share. Slideshow. There. Okay, everybody see that? Everybody seeing the screen now?
Looking here, looking good here.
Okay. Okay, this is element 4 of the tech class. You might call it review. This is one of the shorter sections, which is good. Same process that I think we've gone through for the other 3 sections. In other words, each section, subsection, A and B in this case, has about 11 or 12 questions. And of those 11 or 12 in the exam, you'll get one of those questions. So that when we get through 10 sections, then you'll have a total of 35 possible or sections with questions. So you get 35 questions on the exam. I'm going to go through both the questions, the whole list of questions. And last time, because I had 6 sections, we just sort of looked at the answers, but we'll look at the questions as well this time because we've only got about 23 or 24 to look at, and it won't take as long. So getting on to it, the first part, there's 3 general topics that are the questions relate to. One is power supply, second is digital operation, and the third is sort of station setup, how you put the various pieces of equipment you would have in a ham radio station together. Power supply, I think the main thing to remember is that amateur radios run on 12 volts DC. Your home power supply is 110 AC. So to get the power to the level you want at 12 volts, you need to either run it off a battery. Your car battery is a 12 volt battery. The other thing you can do is run a power supply, which is basically a step down transformer and inverter, taking your 110 volt AC power supply down to a 12 volt direct current. So those are the 2 primary ways you're going to run your radio, either off a battery. If you're out in the field, that's the general way you do it. You can run it off a generator in the field, or and then your Obviously, if you've got a little handheld radio like a walkie-talkie, that sort of radio, then you're going to have batteries in the unit itself. Batteries are generally are rated as amp hours. In other words, ampere is the current. And so if you have a device, a radio that draws 10 amps and you've got a 10 amp hour battery, you can run for 1 hour. Or conversely, if you've got a battery or a radio that takes 1 amp, then you can run it for 10 hours on that same battery. The other second section that we're going to talk about here is a couple of questions on digital operation. Digital has become a very popular subset of ham radio. You typically think of the ham radio operator as somebody sitting at their radio and talking to somebody around the world on voice. But an awful lot of radio these days is done with your computer and with software and what we call a sound modem or a sound card. So basically what you're doing is interfacing, in other words, your radio voice waves, you're converting those back and forth between digital. Your computer's digital, so it's got all these bits and bytes. And then with the sound card, you convert that into the radio waves, send your digital traffic over the radio waves, and then at the other end, or when you're receiving some digital traffic, then your sound card, sound modem will convert it back into, if you're getting into the computer, then you can read it seeing on the screen of your computer. And what we call a DX, the long distance communications, I read recently that 2/3 of all the digital communications, the DX, long distance communications, is now done by digital software. So it's been a big change, and we'll talk a little about that in some of the questions. The last bit is station setup. Just what are some of the pieces of equipment that you need to know about if you're going to set up a ham radio station, and how do you put those together? So let's just run through the questions. Okay, one of the things I think we would have had earlier in the course was the power formula. Other words, power, I'll probably forget it now. Basically amps times voltage equals power, or vice versa. Anyway, in this case, the question is, for a typical 50-watt output mobile transceiver, and that's typical. If most people starting out, in addition to getting a little handheld radio like a walkie-talkie, they will get some sort of what you might call a base radio or mobile radio, which will typically have an output of 35 to 50 watts, somewhere in that range. Now, if you read the syllabus, and some of you may have the syllabus as well as just the question pool, the syllabus answer says that, well, typically to get a 50-watt output, you might need a 100-watt input. And so we know that amateur radios run on 12 watts, so 100 divided by 12 is about 8 amps. From the answers here, we know that A and C aren't right, because we know that amateur radios run on 12 volts. In the case, most power supplies, if you buy a power supply, it'll be putting out 13.8, so a little more than 12. And in this case, if we figured out that 8 amps was probably where we were, then 13.8 volts at 12 amps is the right answer. And if you look at the specs on any sort of a radio like this you might be buying, that's going to be typical. Make sure your power supply has 12 to 15 amps at 13.8 volts. Okay, second question. Why are short heavy gauge wires used for the DC's transceiver's DC power connection? Basically, shorter is better. In other words, you want to minimize the loss of power, the voltage drop over a distance, which can happen with any sort of electrical connection. And that is indeed the answer. So to minimize the voltage drop when transmitting. Okay, we just learned this. How do you determine the length of time that an equipment can be powered from a battery? So we wanted to know how many amp hours the battery is and how many amps does our equipment take. So divide the amp hour rating by the average current draw. In the case I gave you before, if you've got a 10 amp hour battery, a 1 amp draw, you've got a 10-hour life on the battery. What should the negative power return of a, where should the negative power return of a mobile transceiver be connected in a vehicle? Okay, we've already mentioned before, you know that your batteries in your car are a 12 volt. And if you've ever had to use jumper cables to start another car, you want to make sure that one of yours gets attached to the chassis ground for the 12 volt battery, which is the same answer here. In other words, you want to make sure that your equipment is grounded the same way as the 12 volt battery in the vehicle. Okay, moving into digital. How are the transceiver audio input and audio and output connected to a station configured to operate using FT8? Okay, a little background. FT8 is one of the digital modes. It's very popular for high frequency HF transmissions. People use that to decode, make connections all around the world. The software is giving away the answer, WSJT-X software. Now the JT in WSJT is Joe Taylor. He's a Nobel Prize winner in physics, and he developed this software. And this is one of the more popular digital modes. And you recall earlier when we talked about connecting your computer to your radio, what we're talking about is the audio. We need to convert audio input, output to digital. And so, knowing all that, you can figure out that the answer is to the audio input and output of the computer running the software. The others mention FT8, some of them, but the main thing is to think about audio input and output, computer connections between the radio and the software. Again, remembering what the concept is with digital communications and radio, what signals are used in computer radio interface for digital mode operation. Okay, we're audio. We're trying to convert audio signals, radio into the computer. So the important computer connections are the receive audio, transmit audio, and also so we know when we're transmitting the transmitter keying. And again, the key here is audio. Think audio, computer radio interface is an audio digital connection. Similar question, which of the following connections is made between a computer and a transceiver to use computer software when operating in digital modes? Okay, this can be confusing since all of these look kind of similar, but the main thing to remember is speaker connections, audio. So we know it's got to be one of the other two, the last two, C or D, and it's not the same on all computers, but line in is usually what you connect any other audio devices to your computer. If you put a microphone on your computer, put any other audio devices on your computer, it'll go to the line in. So that's how to remember that, which is the correct answer. Okay, this is if you've got a cell phone, just think about cell phone hotspots if you're familiar with those, and that'll lead you to the answer here. What function is performed by a transceiver in a digital mode hotspot? Again, the way a cell phone hotspot works is generally you're trying to use your phone as a hotspot to connect to some other device. In other words, your phone is connected to the internet and you're using some other device to connect through your phone to its internet connection. And that's exactly what you're doing with a digital hotspot. You're connecting digital voice or data systems via the internet. Same concept. A lot of people will talk about DMR, digital mobile radio, little. A lot of people get into their digital mobile radio, DMR connections via hotspots. And a lot of libraries, in the case of during the pandemic, when a lot of people couldn't get to where they needed to get to, and a lot of online learning, a lot of people were connecting to the internet with hotspots if they didn't have a good connection in their home. Okay, moving on to station setup. This is sort of a general, this is a setup of somebody. It has specific equipment indicated here, but the important thing is just the way things are set up, because this relates to several of the questions we'll look at. Now, down here in the lower left, this little box is the power supply. We talked about that. Now, in the transceiver here, transceiver, transmitter, and receiver in the same box, you'll also have typically a microphone attached to this. If we get into digital, then you're going to have a computer attached to that. We know what that's for now. And then you may also, if you're into Morse code, what we call CW in amateur radio, you'll have a key, the clickety clickety click that you've seen in all the movies. So that's your starting point. And then in this particular case, we've got a power amplifier. So this means that this guy wants to increase the power that his receive transceiver is putting out. So he's got a stronger signal. And then the signal goes from there through a meter that sort of measures the power at this point. And also it's an SWR meter is listed here. We'll talk about that a little bit. SWR is standing wave ratio, and that's the ratio of the power going to an antenna versus the power coming back. In other words, you want all your power, as much power as possible, going from your radio to the antenna. If it's not, then you're losing a lot along the way. And then in this case, you've got an antenna tuner. And what you're trying to do with the antenna tuner is, depending on the wavelength that or the frequency that you're trying to transmit on, you want to make sure that the antenna you're using is in tune with it, is properly tuned, and so is resonant, as we say. And so that's the purpose of the tuner there. And they show here is a dummy load, which means that you can check your antenna. You never want to turn on your radio and transmit if there's no antenna attached, because that doesn't do good things to your radio. It's rated, as we say, you can turn your radio into a brick that way. But you can use a dummy load, which mimics what an antenna would do, as creating a load on the radio. So these are the way things are generally set up in a ham station. And so let's see what they ask us about it. Okay, which of the following should be considered when selecting an accessory SWR meeting? Now, we just learned that SWR is standing wave ratio. This is to measure how well your setup with your antenna is. And that's going to be on a specific frequency and a specific power level. So that's the answer. So that the frequency and power level at which the measurements are made are covered in the range. It's sort of like a volt ammeter. If you look at the scales on that, you don't want to use a scale that's inappropriate to the voltage you're measuring, or you're going to burn out your volt ohm meter. So again, this is the answer here. Similarly, where should an RF power meter, we saw that in the picture as well, be installed? Well, we saw that in the feed line between the transmitter and the antenna. And there's another picture of another sort of setup, even more simplistic. Transceiver, antenna, and then measuring both the power you're getting to your antenna and also whether your antenna is properly tuned or resonant. Which of the following conductors is preferred for bonding at RF, radio frequency? I think this is one you just sort of have to know. In general, thicker solid copper is best. And in this case, steel, copper is the best conductor. Steel is obviously not the right answer. And flat strip is better than braided copper. In other words, copper braided removed from a coax seems kind of silly. You don't want to tear your cable apart to generate a connector for your arrangements. So flat copper strap. And that's what flat copper strap looks like. I don't have personal experience with it, but I'm sure a lot of other hands do. Okay, what is an electronic keyer? Well, we talked about what do you use for Morse code, a key. And so you can sort of deduce from that is a device which assists a manual sending of Morse code. Now you can have software that'll send Morse code for you. You can have various types of electronic keyers, and that's basically the answer. So key, Morse code is the thing to remember there. And that's the first half. So you'll have one question out of that section, and then we'll have one question out of the following section here. Okay, this is two main topics here are radio operation and controls and digital radio. Some of the things that show up a lot, and again, these are specifically here because we're going to see some questions on them. One is squelch. Virtually every radio, either as a knob or somewhere in the programming that you can set it, has a squelch setting. And what the squelch does is sort of a filter. If you turn on a radio with no squelch, you'll hear a lot of noise. And what the squelch does is filter out the noise. So you turn up the squelch a bit, and all of a sudden, hey, the noise disappears. What that means is that the squelch control is cutting out all the noise. There may be some signals in that noise, but you're saying, okay, I just want to hear the strong signals. So the signals that come in with the squelch tuned up a bit are the ones that you're going to hear. And so it's always, if you're hearing a lot of noise, you can almost always adjust the squelch knob on your radio so that you don't hear the noise and you're still hearing the strong signals. The second item here is a VFO. We've got a question on VFO. A VFO is a variable frequency oscillator, and it's basically your tuning knob. So every radio has a VFO in some fashion. And so if you just want to tune across the entire band, then you just turn your knob, and you can see either the dial or the digital indicator going across the band. The other way you can get to the same frequency is through putting it in the memory bank. Almost all radios these days have a significant memory bank. So you can store, the typical radio, you can store 1,000 different frequencies in. Typically, you're storing frequencies in the UHF, VHF, and when you get your tech license, then that's what you're going to be using primarily. And so most memory or VHF, UHF things are specific frequencies. In other words, 146.580 or 146.520, which is the national calling frequency for VHF. The other question, there's a couple of questions that mention SSB. SSB is signal sideband, and that's, if you look at a signal, particularly an HF, you'll have a couple of sidebands to it. I'll show a picture of it in just a second here. And those are three areas that we will have some questions on. The other bit we'll have some questions on is digital radio. And again, we talked about digital radio and the connections previously in the first section. In other words, converting your voice into digital and vice versa. And DMR is a format of digital radio. It stands for digital mobile radio. And it's basically it uses a narrower bandwidth than, in other words, a lot of radios are either wideband or narrow band. It just says what the wavelength, the width of the band is in megahertz or hertz. Connections via the internet. The other thing that you remember about most of these digital modes, particularly ones like DMR and this other one mentioned here, D-Star, is that they go through the internet. In other words, it's similar. There's a convention or repeaters that can transmit your signal around the world on the internet through repeaters. DMR works the same way. So you get into in my area, we've got a DMR repeater, 2 DMR repeaters within about 30 miles of my house. So I can take my DMR radio, connect into those repeaters. The signal is transferred around the world or wherever I want it to go via the internet. And D-Star is a similar sort of system, which is a proprietary system, but it does show up in a question. Just a brief summary on signal sideband. This can get a little too technical, but basically on a general and a signal, a wave, you've got a carrier wave and then 2 sidebands. And it turns out that the information transmitted in the carrier and the sidebands is equal, and you've got a narrower wavelength on your sidebands. So if you put filters into the radio that suppress the carrier and the lower sideband, you can transmit the same amount of information with just one sideband, in this case, the upper sideband, a lot narrower bandwidth, and so a lot more efficiently. And that's why signal sideband is used quite often. You generally see it on HF, the higher frequencies, rather than the VHF, UHF. Okay, let's look at the questions here. Again, there we go, SSB transmissions. Now, I think that the thing to remember on questions like this, whenever you've got a question that says something like, what is the effect of excessive microphone gain on SSB transmission? This is going to be something that's going to mess up your signal. In this case, it distorts the transmitted audio. It could be instability, but really, I think the distorted transmitted audio is the answer here. Okay, we've just gone through this. Which of the following can be used to enter a transceiver's operating frequency? We just went through that. You can need the VFO knob is what you're going to need. A keypad is also a way you can do it. Most radios nowadays have, with your microphone, has got a keypad on it, just like your mobile phone. And so you punch in 146 or 146.520 would be the national calling frequency, and then it would show up on your screen. And these days, pretty much every radio has a screen on it. You're just not looking at dials anymore, you're looking at screens. So keypad or VFO. And again, we just talked about this. What is a quick way to enable access to your favorite frequency or channel on your transceiver? Well, if you're not dialing it in on the VFO, then you're going to pull it out of the memory. So all you have to do is hit channel 3 or whatever, and immediately are on the channel you want. You don't have to tune to it. What is the result of tuning an FM receiver above or below a signal's frequency? This is sort of, if you listen to my section 1, sort of stay in your lane. So if you're a little off frequency, and sometimes you'll hear somebody on the radio, we say, we're going to be on 146.520, and somebody has their radio inadvertently turned to 146.525. You might hear them, but they're going to be a little off. So you got, again, distortion on the signal's audio. And similarly, there's some digital modes that your signal can be slightly off. And I mentioned that you've got a translation element converting your radio signals back into digital. And if the frequency is a little off, then the bits and bytes get kind of lost and you don't convert it. And that's another thing that can happen if you're a little off on frequency. How is squelch adjusted so that a weak FM state signal can be heard? Okay, we talked about this. As I say, if you want to listen to the weak stations, normally you want to adjust your squelch so that it's at a level so that you don't hear all the noise, which could include weak stations. Okay, but we want to hear the weak stations because there's somebody out there we're trying to get, and we think they're going to be pretty weak because we know they don't have a very powerful transmitter. Then we want to set the squelch so we hear everything. And then the challenge is to pick out a very weak signal from all the noise you might get then. Just understanding how squelch works makes this pretty simple. Okay, what does the scanning function of an FM transceiver do? Well, everybody's heard about police scanners. What does the police scanner do? It scans the police and fire frequencies so that you can listen in and find out if there's any interesting disasters going on. Same thing happens here. Tunes through a range of frequencies to check for activity. Typically, as a new ham, you might get on the radio. I think it's often frustrating. For example, I mentioned the national calling frequency. You say, "Oh, great! I'll get on the national calling frequency and talk to somebody." Nobody there, and I have rarely found anybody on the national calling frequency. But what you can do is set a scanner, the scanning function in your radio, to scan a whole range of UHF or VHF frequencies, and then you might come across a net and you say, "Hey, there's somebody talking." Then you can sort of introduce yourself and get somebody to talk to. Because one of the most frustrating things I know for new hams is, gee, there's nobody I can talk to. How do I talk to somebody? Okay, which of the following controls could be used if the voice pitch of a single side, and there's our single sideband again, returning to your CQ calls. CQ is, I want to talk to somebody. Calls seem too high or too low. This is one I think you just have to sort of remember. The answer is the RIT or clarifier, receiver incremental tuning. It's that sort of a fine tuning in your radio. AGC is automatic gain control, and that's also a sort of a fine tuner. That's basically to normalize volume is the AGC. The RIT is more of a fine tuning on the, well, I'm not sure I could explain it any further. So that's just one to remember. Okay, what is the advantage of having multiple receive bandwidth choices on a multi-mode receiver? Now, I talked about DMR receivers. DMR receivers have a narrower bandwidth, but they also operate in other ranges, UHF, VHF, at what we call analog. And so that would be what you'd call a multi-mode transceiver. So if you think about that and look at the possibilities, then the one that jumps out is B. Permits the noise or interference reduction by selecting a bandwidth matching the mode. So if I know my DMR mode is going to be a narrow band, and I'm also looking at listening to some wideband UHF, VHF, then this is how it would be a benefit for me. And number of frequencies stored in memory, that doesn't really work. Offsets have to do with repeaters. So this is really the only answer. Once you understand there can be different bandwidths and different choices on a receiver. Okay, this is one that I think is probably the most, unless you have the right book, I think. I've looked at this question. This question was on my exam when I took my first exam, or tech 10 years ago, 11 years ago. And the thing to know here is you need to know, I think, really, is that the question is, which of the following receiver filter bandwidths provide the best signal to noise ratio for SSB reception? Now, the human voice frequencies are in the range of 300 to 3000 hertz. And I'm going to read you the answer on how you pick the answer here. This is from a radio expert friend of mine. Because when I looked at it, I had no idea. I just had to memorize the answer. He says, from the knowledge that the voice frequency ranges from 300 to 3000 hertz, a filter less than 3000 throws voice information away. A filter much greater than 5000 includes too much noise with no additional voice information. So 2400, a 2400 wide filter will pass most of the voice signal with no additional noise added. Best signal to noise ratio. The other way to think of it is, remember the human voice, 300 to 3000, well, 2400 sort of would fit in there. So if you've got the syllabus, this is what was in the syllabus. Syllabus is an explanation, and I don't understand. So I think if you think in terms of the human voice, 300 to 3000, you're in better shape. 2400 is in the middle, and it's going to cover most of the voice frequencies.
Jim, I could
Okay.
add a little insight on that, I think.
Yeah,
So what's the width of a single sideband signal?
good question. I don't
Listen-
remember off the top of my head.
Yeah, it's about 2800. But it really depends on, you know, what the power is, and you know, a few other things. But when you put those other filters in there, they start narrowing that down more and more and more. And if I put a 500 hertz CW filter in, I can't understand what's being said. It narrows it down that much. But that's only because I've got the experience on it. I don't know how to calculate it, just like you. But there are different filter sets that will keep narrowing down that signal until it's completely unintelligible. And I think that 2400 is probably a good range to be in. You'll notice a lot of the websites will sell different filters, and they'll have CW filters and they'll have single sideband filters. And you'll notice that the frequencies are quite a bit different on them. So that's kind of a little bit more insight. I don't know if it helps people with the answer, other than the fact that they should memorize 2400.
Yeah, I like, even though it's technically not necessarily the right one, is that if you remember 300 to 3000 for the human voice, well, gee, 2400 sort of sits in the middle of that. But that'll get you the right answer, as long as you don't have to explain it to somebody. Okay, moving on to next question. Which of the following must be programmed into a D-Star digital transceiver before transmitting? Okay, so let's go back to FCC rules. What's number one FCC rule? When you're on the air, you need to identify yourself. And you might think, well, if you look at any digital transmission, pretty much, somewhere in there is going to be your call sign. You need to put it into the software. And so you are identifying yourself. If you're in a DMR, look at the little screen in your DMR radio, you'll see the call sign of who's calling you. And so this is an identification question rather than anything else. Your call sign. Okay, what does the DMR code plug contain? Okay, a code plug is basically a programming. It's basically a spreadsheet that's programmed into your radio, which contains all the information the radio needs to communicate with other DMR through the DMR system, you might say. code, I don't know how the code plug came up. But that's it. Access information for repeaters and talk groups. In other words, Steve and I talk every Sunday on a DMR net that our radio group up here sets up. So we have a talk group. That's another term you'll hear in DMR, talk groups. Talk groups are like chat rooms. And so Steve would know that our group, our net, our discussion goes on talk group 31538. He can figure out where that is in the DMR system. And so his code plug, his programming and his radio will tell his radio how to find my radio through the DMR system. And that's how the code plug works. For example, the code plug also can include all the other people that have signed up. You have to have an address on DMR, on the DMR system. And so you can have like 40,000 call signs in your radio. And so if they're programmed in, then whenever somebody calls, when Steve calls on our net, Steve call sign pops up on my radio. So I know that it's him. The other, yeah.
Oh, I was going to say the term code plug actually came from early commercial radios when they were using digital signals. They actually had a physical plug that plugged into the radio that had all the stuff already programmed in it. A lot of times it was done with wires and filters and things like that, but it was a physical plug that you put into your radio, and that's why that term is still used.
Yeah, and DMR developed from a commercial system into amateur use. The other software, again, we talked about software. In all of these digital systems, you need to have the software. And in this case, you need to have what we call the firmware, the DMR software. In addition to the code plug, you have to have the right version of the DMR software in your radio as well. How is a specific group of stations selected on a digital voice transceiver? Well, it's the same. We just talked about the talk group that I host on Sunday nights here has a specific identification code, 31538. And that's how Steve and his radio can find my talk group by entering the group's identification code. And that's it. So any questions? Again, this is the shorter one. So only 2 of these questions, and there's only 24. And hopefully with some of the background, you'll be able to pick out the answers quickly. Okay, I'll stop sharing.
So Marlena, how are you doing on the studying so far?
Well, I haven't studied that much, but I will. I've been meaning to look at the flashcards. And it's hard because I'm juggling working here at the same time here at Mother Nation. Yeah, so I'm thinking hopefully I'll pass the exams in December.
Well, that sounds good. I just want to make sure you're making progress so that if you need any help on anything, we can get you the help at the right time so you don't get overwhelmed.
Right, thank you. I appreciate that. I'm hanging in there.
Well, I'm going to go ahead and stop the recording until we start up the presentation.